Okay, good morning, everybody. Welcome again. This time we have for our deep seminar our own Merijn Moody. He is a PhD student here, so one of the guys from Deep. You also studied here at the IPA physics, but also did a mathematics, but also has a background in philosophy. So we're not only getting the background into the physics and mathematics of LLMs today, but also more on the philosophical side, I guess.
Yes.
So it's going to be an interesting talk today.
Yes. Thank you for the introduction. Yeah. So this is about something quite different from what I'm researching now. So this was what I did for this research I did for my master's thesis in philosophy with a number of people at Radboud University and Ghent University. Um, and yeah, basically it's about benchmarking understanding and creativity of LLMs. So yeah, maybe a quick outline. First, I'm going to be giving a little bit of context of, the problem, why we're interested in this. Then I'm going to be talking about scientific understanding and creativity. And then at the end, I'm going to be talking about a way to benchmark this, a way to measure these things. Um, yeah, so starting with basically a bit of the context about the problem. So as I'm sure everyone is well aware, is that LLMs and AI is playing an increasing role in science. And this begs the question of what is the role of LLMs in scientific discovery? What can this role be? There's been a number of people who have thought about this, and especially in recent years and months, this the role of LLMs in AI and science has shifted from basically this computational microscope thing where you are using AI to do complex calculations to get insights in that way to the language side as well, to understanding, to creativity. And then this has also led to a lot of replies and discussion from the philosophical community. And basically, there have also been people there that have said, LLMs cannot have this creativity, they cannot have this understanding. So there's a couple of things. You have this epistemic opacity, which is basically the property we don't know what's going on inside the LLM, so we don't know what it's doing. And then you combine this with what's called this famous, which basically saying is that LLMs are only trained on next token prediction. And therefore, they only parrot the data. They can't go beyond the training data. It's about form. There's no meaning. There's no grounding in reality. And basically, her point is then that LLMs cannot have creativity. They cannot have understanding, and this would have pretty profound impacts also on the role that they play in science, saying that they cannot do.
Epistemic opacity, doesn't that also hold for our brains? We also don't know what's
Yes.
in
So
the
I mean, but yeah, for your own brain, yeah, for other brains, definitely. But for your own brain, you have at least some idea of what's going on in when you're doing physics, right? So then you know that, yeah, you're doing reasoning, you're doing these steps. With LLMs, it's definitely more of a black box than, what's going on inside your own brain. So if you produce a paper, you know yourself, oh, I did all these reasonings, I did all these things, I did this computation. You know also for yourself that you didn't copy this from somewhere obscure. With an LLM, there's always kind of this argument that you can make, oh, it's somewhere in the training data. Um, so in that sense, there's kind of, yeah, also a mismatch also because indeed there's a big difference in that LLMs, they have this huge training data that they have seen. So you can kind of always say, oh, maybe it's somewhere in the training data. So that's kind of, yeah, a mismatch there why the LLMs are even more epistemically opaque. Um, yes. And so what I'm going to be talking about is kind of more functional approach to this question because I got this experimental philosophy, so it's a bit of a joke. But basically, the idea is that these statements that we're talking about this this stochastic parrot hypothesis, they have implications about the real world. They have it's falsifiable in some sense, which is why I think it's appropriate to do this kind of experimental philosophy here, where basically what I'm going to be talking about is giving these more functional definitions of creativity and understanding in terms of behaviors, and then we can question, do LLMs currently exhibit these behaviors. And then I'm not going to be talking much about metaphysics here today, and I think there's a role for metaphysics, and I think it's nice, but I think in this scenario it's important to first look at what's going on, and then hopefully the metaphysics can learn from this and explain what's going on instead of rejecting it. So this is in broad lines what I'm going to be talking about. So giving these functional definitions of understanding and creativity, and then at the end saying also a bit about a proposal to measure them. So firstly, I'm going to be talking about creativity, and this was mainly the subject of my master thesis, and we're also preparing a paper about this, which will be out before the summer. And what I'm arguing there is that creativity should be characterized in two different ways. We can call a product creative and we can call a producer creative. And I'll say a bit more about why we make this distinction later. But for the product, product maybe produced by an LLM, by a person, we usually call that creative when it's novel and surprising and valuable. And basically the main idea here, the most important part is this novelty. So this is really kind of the core idea of creativity, is producing something new. But these extra qualifications about value and surprise, they are necessary because there's many kinds of trivial or nonsensical novelty. So I mean, there's many things you could do that would produce something novel, which we would not call creative. Yes, and then at the end I will say a bit more about there's some examples also of people who have produced things that would be judged to be very creative, but they did this in an accidental manner. So there's also kind of a mismatch there between just producing creative products and being creative. And I will talk about that later. So I will talk firstly, say a bit more about this surprise condition, which is on the product side. So when do we call a product surprising, which is kind of a measure of novelty? And yeah, basically the main thing that this why you need this surprise condition is to rule out trivial novelty. So you could, take a book, you could change a letter, maybe you fix a typo, right? You produce a novel work, which is, it has never been existed before. And, maybe it's also valuable because you fix a typo, but still we wouldn't call that creative. Or, you could do something else. You can multiply two random numbers. Probably nobody, if you make them large enough, nobody will ever have done that before. And you also don't want to call that creative. And then, you need a bit of this philosophical language. So this is something introduced by Margaret Bowden. So this idea of a conceptual space. So this is a bit of a philosophically loaded sentence, but she says the dimensions of a conceptual space are the organizing principles that unify and give structure to a given domain of thinking. And basically the important thing about this is that usually within kind of a domain of thinking, so like for instance mathematics or a subfield of mathematics, there are certain generative principles that are used to produce new products in that space. So for instance, in mathematics, you have certain axioms that you can use, there are certain theorems, there are certain proof methods, and these are kind of the rules that you learn when you learn the field of how to produce new proofs or new papers within that field. And then basically the idea of Bowden is that when you break with these principles in some way, then you are really producing novelty, which is not trivial, which is surprise. And then she also gives this classification, of different types of creativity. So you have combinatorial creativity, of using different kind of domains and applying them together, mixing them together. And then exploratory, which is, basically probably the most common one, where you're using these rules, but still you're doing something new, right? Maybe you're where it's not a priori known what you're going to do. Maybe you give a new proof for something. Maybe you're still following certain procedures, but you're not following them with a step plan. Like when you're doing some sort of computation, beforehand exactly the steps you're going to do. That would not be creative. So exploratory creativity is kind of mixing a little bit with these steps. And then transformational creativity is kind of the most creative form of creativity, the most radical form, where you're really breaking with the rules of the space and really doing something, producing something very new. That's a question.
But does this mean that in this definition, just the vast majority of science is not a surprise?
Well, I mean, I would say I think a lot of things fall under this exploratory creativity, and it's also kind of, a quantitative thing. So I would say it's not something that you would really use qualitatively that much. So I think a lot of things they have some measure of surprise, but maybe not very much. Yeah.
But so in the language of LLMs, LLMs can be very good in doing exploratory science then, or
Yes, yes. So this is also where I'm going. So indeed the LLMs. Yeah, so indeed, in this sense, when we're looking at LLMs, like the products they're producing, I would say that they definitely fall under this exploratory creativity. Yeah. Right.
Is here, it's very concrete research and but this is a very kind of philosophical framework.
Yes.
But we already have available to us very, very precise measures for novelty and creativity. And I'm curious whether the processes are trained on these in patent law and intellectual property law.
Yeah, so I think it's probably related in that sense, but I'm not, I didn't really look. No, I didn't look at that much, but I do think that for patent law, I think they also have kind of this idea. I think they also use a similar notion of creativity there.
No, I was thinking in the other direction is that you could use all of that text, all of that precedent, and the laws that are written in all of these three countries to train on for determining creativity.
For determining no, that's interesting idea. I haven't really thought about it.
I was just curious.
No, I don't think so.
Such a rich.
No, it's
I had another question about the last transformation of
Yeah.
the rules thing. I mean, that sounds like you can do this in many different invaluable way, right? I mean,
Yeah, definitely.
It sort of contradicts the other.
No, so I mean, so I didn't talk about it that much, but you also need value, right? So you need surprise and value. So so this is also, you need surprise, but you also need value because there's also nonsensical surprise in it.
how does this work in mathematics? I mean, you can have surprising ideas in mathematics, but they are always based on whatever axioms you start with.
So I would say that also the way in which you combine the axioms, right? Like I said, there's certain proof methods maybe that are common in mathematics. If you do something and you know beforehand, okay, I'm gonna follow these steps and then I get this result, then probably it's not creative. But when you're looking at some problem, you probably don't know beforehand exactly what you need to do. So in that sense, I would say that still these products in mathematics can also be creative, even when they arise from axioms.
In our work, we connect this to optimization problems and the discussion about NP-complete problems. So we agree that because it's finding improbable solutions in a search space. So you can make it quite exact by using the concepts of search spaces.
Yes. So I agree. But then, probably it's gonna be harder to apply because I would say most things that are being done in the world in terms of things that are being produced are not easily put into like an algorithmic framework, I would say. So these are just some examples of kind of this type of exploratory creativity, but there's many more of these. I think one of this is like this proof that was given by an LM of this of a thing in algebraic geometry, and also verified by a professor. So I think in that sense, it's quite clear that LLMs are capable of producing surprising products. And then you still have this producer, this agency condition, and basically there's also been the reason that people include this in the literature about creativity is there's one one famous example that people go to, which is Charles Goodyear, who discovered the vulcanization process of rubber, which is actually a pretty big discovery in its time. And basically what he was doing, he was interested in rubber, and he was just applying random things to rubber. Like he put honey on rubber, he put soap on rubber, he was putting all kinds of things on rubber. And then at some point he put sulfur on rubber, and then he accidentally also dropped it in a fire. And then he discovered this vulcanization process. So, he was not going about it in a principled way. He didn't understand anything about rubber, and it was also an accident in terms of he wasn't planning to put the rubber with the sulfur in the fire. And people would really want to argue that this is, and then people argue that this kind of vulcanization process of rubber really changed this conceptual space of, rubber and what you can do with it, so that it's, and people say that, this is not a creative producer, right? You don't want to say that Charles Goodyear was a very creative person because he was just doing random things. And then what people say introduce is kind of.
Not sure if I got it. I'm really close. He had a project that people believed could be useful, but wasn't useful in the current form.
Yeah.
So he started the whole world. So he didn't do it any more idea space or that, because the whole world knew that if you could stabilize rubber in some way and make it useful, you would become the richest man on earth.
Yeah.
So that was what he was doing.
Yeah. So I mean, so he was, so in that sense, there was some purpose to it. I agree, but it was also an accident, right? Like he didn't. Yeah, it was also random in that sense.
He was looking for it.
Yeah, no. So I mean, you could probably say there's some creativity there, but I think also the point here is that this is not in terms of transformational creativity, you would not call him a radically creative person, right? In terms of comparing it to mathematicians, or maybe there's some maybe. No, I think it's interesting that if you have a different opinion. Like for me, this is I find this not to be very creative, but
I think in creativity literature, this is really what everybody.
Yeah, no, this is true.
You have to be. So if people just find by accident or by just random trying, you don't consider this as a creative process.
Yeah, I mean,
product, but in terms of process,
in terms of process, there was not. So I mean, no, this is it's a good point, but
this example maybe is debatable, but the general point.
No, I think that the point in general is that when you do something by accident, when you're very lucky. But I think also one of the things is that, this is not reproducible, right? If he was like a very, if he really was investigating rubber from, a scientific perspective, and he had some ideas about this, and then, he arrived at this conclusion in that way, then, you could also argue that maybe he had produced more creative products later. He could use also the thing better because he could understand why it happened in that way. So in that sense, I also think there's it's more also about a correlation to, how much creative output someone has. So if you do something by accident, then, probably there's not that much potential for doing that again.
Just to kind of clarify the category.
Yeah.
So the invention or discovery of penicillin, where does that fall? Or the invention, discovery, what is it, latex that came from milk?
Yeah, so from penicillin, I would also say that, I think, I also, in the paper I have a bit more about that, but I think there the point is that this was also kind of random, but there was definitely more skill involved also in recognizing the potential of this and, giving explanations of why it's happening in this way, and then also, kind of making it more broad in some sense. But I don't have all the details right now, but
Why do you connect this to agency? Because my reading of literature, it's really about the process. So if people just use a random search, even if they have the purpose to find something, but they use random search to find a solution. They are just lucky, so early in the random search they find a solution. we will still not call it a creative process.
Yeah, no,
It has
so
nothing to do with agency, I would say, but more with the search process.
yeah, so I agree with that. So and yeah, this is also a good point in terms of when you're looking at it from like more of an algorithmic perspective, like you're looking for something, right? And then you're looking for ways to go there. You can do indeed you can do a random search like what Goodyear was doing, and then you could also get there by luck. Or you can have like more of a heuristics, that you're going in the right direction, but you're still exploring different things. I think this is kind of the main idea that we want to capture by this. And I would say that I would understand this agency condition as kind of, something that correlates to how well you are doing this heuristics in your search, how well you're constraining your. I think I would say that that's the way I understand it. This is kind of something that correlates to the degree to which you are capable of, doing a directed search instead of a random search. Yeah. But I mean, so I would agree that the main point of introducing such a condition is to basically argue that uh, to the extent to which you're capable of constraining your search space instead of doing a random search. I think when we're going back to these products of LLMs, I think then this is already clear that this is not, a random search. I mean, if you're doing a random search with improved space to find, a proof of these these mathematical things, you're never going to find. I think that's
But
quite clear.
that's my problem, because giving agency to LLMs, that's a whole other discussion. So
Yeah, so
they do a non-random search. In that sense, it's a creative process, but giving them now agency is a whole other thing.
yeah, no, I agree. So I'm not saying that, LLMs have, agency in the full sense. I think that, again, there's a lot of, so I didn't delve too deeply into, this whole discussion of agency, but I think when you look, so in the creativity literature, there's also this definition of agency by Flair, and then agency is associated to these four conditions. So there's this purpose, there's understanding, there's judgment, and there's evaluation. And I think, yeah, so I'm still thinking that, it's interesting to also investigate LLMs in these terms. So I have a few things about this, which is that, for the purpose, again, that's a whole discussion, but I think in this sense, right, when you're giving it a prompt, it's not random because you want something, you're saying, go look for this. So that's what I have to say about the purpose. But then for the understanding and judgment, so understanding I'll come to a bit later, but here you can also bring in reasoning a little bit, and then I think this is an interesting topic as well, because there's a lot of evidence that LLMs do have quite a bit of this memorization, or they use heuristics, so they don't have kind of this very solid reasoning that you can see in humans. But there is definitely some generalization happening, because it's more than just memorization, because they cannot memorize the whole training data. So I think in terms of understanding and judgment, they're somewhere in between, humans and random search. And then I think there's one other property which is quite interesting, which is this evaluation, because this is also kind of one of the main paradigms of LLM research right now, which is test time inference, which is basically, also the word agency is also getting thrown around a lot in LLM research. You have all these agents being introduced by Claude, by all the big companies. And basically the idea there is that, you give an LLM a task, but you also give it some way in which to iterate upon the task, to evaluate its own output and to think of ways to do it better. So I think this is quite interesting also in terms of relation, that this is, in the last year and a half, this has been a major topic of research, and has also led to a lot of improvement in LLM performance. So I think this is just quite an interesting connection here between, this theory of creativity and these kind of correlational properties, which, correlate with producing this search space, and then also seeing that this is one of the big current topics of investigation in LLMs, and seeing that it really makes quite a bit of difference. But yeah, I mean, the verdict here is, they have the real capacity for producing creative products, and they have some limited agency right now. But I think the main thing here is that, when you're looking at stochastic parrots, I think it's quite clear that, they are not just stochastic parrots. They cannot produce these things by being stochastic parrots. I think when you look at the original stochastic parrot paper, they also have some pretty debatable claims about LLMs never being able to do arithmetic and things like that. So I think in that sense, this really calls also for, another evaluation of how we're thinking about these things.
Which year was this suggested?
Yeah, so this was quite a bit. Yeah, so I think they looked at GPT-2, so this was quite a bit of time. Okay.
The last version GPT is using is created by help of the previous version to rewrite the code.
Oh yeah, it could be. I don't know.
And
Yes. No, I think. Okay, so then I'll switch tracks a bit to scientific understanding, and this was mainly work done by Henk de Recht, who is he has a influential account of understanding, and he also kind of thought about this question of how do we apply this to LLMs without there's also in the literature sometimes people that preclude LLMs beforehand just because they're not human, because they don't have these properties. So there's some adaptation that needs to be done to apply this theory of understanding to LLMs, to agents in that sense. So the original theory of understanding is that scientific understanding is something that's produced by explanations. And these explanations can be objective, but the understanding is dependent on the subject and its context. So basically the idea there is that understanding is, it's a skill, it's an ability, it's how you answer questions. So it's not just about these explanations. And then basically one of the main concepts here is that scientific understanding of phenomena requires intelligible theories. So they require theories that you can make sort of qualitative statements about without really going into the math.
He never defines intelligible.
Intelligible, yeah, he does define it. So I don't know if it's here. No, I think from the top of my head, what he says is that a theory is intelligible if you can make qualitative judgments about phenomena without going into the math. I think it's something in that direction, basically, that you can use it to make qualitative statements without, computing everything. But again, this is also not entirely my domain of expertise. And then, so on this account, when you take this at face value, then it's about cognitive skills, it's about mental representations. So you want to find some way in which you can also kind of translate this to LLMs. And then this is also basically what I was saying for the creativity, but you want to assess understanding in terms of behavior. So in terms of like a functional theory, not just a conceptual theory. And then this is the subject of another paper, which I was not involved in, but basically here they proposed some way to benchmark scientific understanding in LLMs.
Can you show the previous slide from
Yeah.
because now do you want before?
Oh, yeah.
Because you can't read the text actually.
Okay.
So, please.
Yeah.
Okay.
That's good. Yeah.
Okay.
And one little, because in our work, we also make the point that somehow when we talk about AI, we make understanding a binary thing. They either understand it or not.
Yeah.
But if we talk about human understanding, it's a very gradual thing. So it's always a bit of a strange thing.
Yeah, no, I agree that, with most of these concepts, it's far better to understand than qualitatively. And I think this is also where we're going here.
Yeah.
But I think when you make this into a binary, then this is not really informative.
But should I try to understand this in some sort of a scientific understanding Turing test?
Yes, in some sense, yes. I think, yeah.
But so I guess that you just have this prompt and you start asking questions like, how well do you understand quantum mechanics? I think it would be quite difficult to differentiate a human from let's say an LLM.
Yeah.
I think that most humans are worse at quantum mechanics than ChatGPT.
Yeah.
Yeah.
No, I think so too. I mean, yeah, this could be. I think this is also a result of this. I mean, yeah. I think this is not something that you want to preclude a priori, right? Or
For the benchmark it, do you then benchmark it against the, let's say, top 10,000 people in the field, or top 1,000, or top?
well, I mean, it's not. Yeah, I mean, it's not about necessarily about. We're not. Yeah, it's not about a human versus LLM comparison. So, yeah, it's more.
We compare it to people, we compare it to children. So we have other class for the benchmark class, and then we really go to classrooms of which we know we do this, collect data about a lot of children, and then we actually see at what age level these problems go. Yeah.
But then these are things that are sort of simpler than telling a giraffe is a giraffe and not.
Sorry?
Telling you like a picture of a giraffe and be able to tell them.
No, these are analogical reasoning tasks. I don't know whether there might also be your benchmark, but let's see about it.
Yeah, no, so it's, yeah. So, yeah, basically their proposal is that, yeah, the ability, yeah, so basically, again, the idea is to identify, an ability to reason and reason about and manipulate objects as the thing that measures understanding. So this is about behaviors. So this is about something that you can measure. And more specifically, they say that the ability to answer what, why, and what if questions is a good measure for of an agent's level of scientific understanding. And then I'll elaborate a bit more on this. So basically what they introduce is this AUP, Agent Understands Phenomena criterion, which is the degree to which agent A scientifically understands a phenomenon P can be measured by, firstly, it should have a sufficiently complete representation of that phenomenon. It should be able to generate explanations of it, and it should be able to establish a broad range of relevant counterfactual inferences regarding P. So this, yeah.
Question about the previous slide. There's this, the whole point of, I mean, raising the questions in the first place, posing useful or valuable questions. I mean, that's also an important part, of course, of scientific research. So where does that sit in this whole?
Yeah, so I would say that
really about answering questions, but
yeah,
posing the question in the first place.
Yeah, I would say that falls more into the category of creativity than understanding. So I think here, as it's defined here, indeed, it's not about formulating questions, it's about finding responses to questions. I think when you're looking at the capacity to be creative, then formulating questions is important, because then you want to find, you want to define a question that's valuable and surprising, and valuable maybe in the sense that it's answerable.
The question would be, so I mean, because you started out discussing this in terms of as being products.
Yeah.
So a question can also be a
a present question can also be a product. Yeah. Okay. So so this is this criterion for understanding for LLMs. So we'll go through this, and basically the what, why, what if questions will correspond to these different points of the criterion. So firstly, the sufficiently complete representation. This is mainly, you can ask this in terms of what questions. What's the color of the car? What is the wavelength of blue light? And I think initially this was something, when they wrote this work, this was something like, do LLMs have this? We're not sure, but now I think it's pretty clear that for most phenomena they have quite a complete representation of this. So I think this is not really that interesting anymore, but it's still a good part of the definition. And then for the explanations, again, then you come to the why questions. Why is the sky blue on a sunny day? Why is the sunlight scattered in the atmosphere? And again, I think for most of these questions, I think LLMs can do pretty well on this. And then I think the what if part. So this is about counterfactual inferences. I think this is more where it gets interesting, where the questions can become quite hard and quite difficult. So what happens when I change these parameters of the theory, etc., etc. So yeah, basically, so that's kind of their proposal, is that these things give a good measure of understanding.
But the first two that you just mentioned, are they just memorization?
Yeah, they could be memorization, but yeah, I mean, again, I think,
It's
yeah,
only the last one that actually has kind of an,
it's true. So
Unfortunately, the last ones are also, because now if you publish these results and these questions, you have this problem with the letter string task, that then this is also in the data. So
Yeah.
in the next iteration, this is also in the data.
no, so this is a general problem of benchmarking LLMs in general, is that they get access to the questions and they learn. So this is a problem. Okay, so that's and then they also kind of proposed also a little bit more of like a community-based thing, like what do we do with this as the scientific community? And they basically had this idea of, I think that definitely the scientific community should play a role in developing benchmarks and scientific LLMs. I think there's some potential there, and for also furthering the use of LLMs in science, making sure that they work well, they do what we want them to do. Yeah. Okay, so that was that part, and I think so kind of building on this question of what's the role of the scientific community in in developing these LLMs, in making sure they work. They also published a more of a white paper about the use of LLMs and more AI systems more generally in physics, in fundamental physics. And basically, this is also they propose also this idea where like maybe building the LLM, the state-of-the-art LLM, that's not really a feasible thing right now for the science community, but there's definitely a lot of other things which are quite interesting. So there's a lot of data around in the science community which can be also used to train these foundation models in different areas. And they propose kind of this idea where you combine these foundation models with an overarching LLM. You can ask questions as kind of, this would be a very good way to, if this all works, it would be a good way to integrate LLMs into the scientific pipeline in that sense. But also this is more, but also more generally, like the question is, what role does science play in developing these LLMs? Because currently a lot of it is in the hands of the big companies, and they propose also this kind of three-stage process where you're doing developing, you're doing reflecting, you're doing evaluating. And basically what I was talking about more now mainly was this reflecting, and then for the evaluation part, it's important to have good benchmarks for all these things. And it's also important not to rely only on the big companies for the benchmarks, because obviously there's a lot of conflicts of interest there. And again, also there's many problems with benchmarks. Like they become saturated quite quickly. LLMs often get access to the training data at some point, or to the questions. So it's really important to actively engage with this. And as a part of this, we published this paper towards a large physics benchmark, which basically combines all of the things I was talking about previously. So it combines this creativity and this understanding, and we propose a framework in which we can create kind of this benchmark that tests creativity and understanding of LLMs. And maybe a bit more about benchmarks. So there's already many benchmarks also about frontier level problems. So really testing this creativity or this understanding in a deep way. Academic level tests. I think this one also these slides are a bit old, so I think the results are now about at 40%, 30%. So it's really going quite quickly in these benchmarks, and this is also one of the problems and why it's I think there's many benchmarks needed. I think you can never have enough benchmarks in that sense. So so this is, I think, a continuous effort of producing new benchmarks, making sure they stay up to date, making sure the models don't learn the questions. So basically what we proposed in the paper is kind of a three-stage process where at the first stage you generate these questions. So We were also playing around a bit with letting LLMs create questions for themselves, which is also interesting if an LLM can create a question that makes sense and that it can't answer itself. But yeah, mainly also these human-made questions. And then we have this evaluation, and this is basically to give a measure to how difficult the question is and to how surprising an answer to the question would be. And then we store the question, and then we also propose kind of a peer review setup. And then at the end, there's the benchmark. So I think the evaluation part, this is the most interesting, also complicated, because basically then the question that you want to ask or answer here is, how do I measure creativity using just questions that can be easily evaluated? So maybe it's a yes. So we propose a couple types of questions, but you always want, for a benchmark, you always want questions that you can evaluate the answer quickly. So you want to automatically evaluate whether the answer is correct or not. And I will go into the types of questions that can be used for that later. But then what we propose to measure kind of understanding and creativity is to basically add 2 scores to the question. So one is the difficulty of the question, and the other is the surprise of the answer. And then for the difficulty, this measures the scientific understanding, and the surprise of the answer measures creativity. And of course, these are a bit, coarse things, because yeah, it's hard. But this is basically what we hope is a good way to proceed with this. Yeah, I mean, here's also the kind of a presumption again, like if you say we have this question, which maybe it comes from like a research paper, and then the author has a question about it, and then you presume that the LLM hasn't seen the paper, and then you say, oh, the answer is so surprising. Then basically the thought process is that if the LLM gets it correct, you assume that if the question is difficult enough, it has to have kind of reproduced the same answer internally. And then you can say, okay, it produced something that was so surprising. And then, yeah, again, there's also a peer review thing that we propose. And yeah, so in the benchmark, we also propose 3 types of questions. And basically, these are constrained by the constraint that you want to evaluate the questions automatically and quickly, because otherwise it becomes unfeasible to manage a large benchmark. So there's ABCD questions, which can be, or of course, which can be of many types and can also be quite difficult. If you make the questions complicated enough, then, yeah, I mean, you still have this 25% chance of doing it correctly, but you still, there's still a good measure there. And then open-ended questions. So this can also be, for some types of open-ended question, you can still automate this using, for instance, by prompting an LLM to produce Python function that implements a certain formula, and then you can automatically check if this is the correct Python function for that formula. And then we also propose a different kind of question where basically it's an open-ended coding question where, for instance, it's about write Python code for a transformer-based binary classifier, which utilizes blah, 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 which does many things. Basically, you give it some coding problem, like maximize the area under the curve or do this classification task correctly. And this is also could also be an interesting source of questions, because there's also in the particle physics community, there's really a system where they have also kinds of coding challenges to promote people working on these challenges. I think that's also quite a nice source of potential questions. Yeah, I think we also ran some experiments, comparing different models doing different things. But this is really quite preliminary. So for the question generation stage, we're still a bit early. Yeah. So this is still something that we have to organize a bit. So mainly Eugene Shalugin and Sasha Caron are now involved with this project. And I think at some point they want to do also more of an advertisement for questions for starting this generation process. But yeah, this is still work in progress. Yeah, that's the thought. Thank you. No.
Or open for more?
Yes.
Great talk, thanks very much. One question I guess you could ask is, scientific understanding in the sense of actually doing science is intimately linked to experimental results and what you do from them. And I guess with the examples of like quantum mechanics, where you ask an LLM to describe how well it understands all the space or something, that feels closer to maths than perhaps scientific understanding being, well, an example of that to me would be if you give an LLM, this is a new experimental result that's been discovered in the last year, or what do we do with the theory then? I guess I'm just trying to understand what's mathematical understanding and scientific understanding, in the sense that you have one kind of understanding which is of extant ideas, and you can ask, does the LLM understand the nuances of what the theory is on this? But then scientific understanding also is something more, right? It's about how you react to.
Yes, I would say that, you know, so this question about, you know, if you have some new result, which, yeah, so I mean, it depends, right? If you have some result from an experiment which can be, which fits within the current theory, I think that's an understanding question, right? Then you say, oh, what if these questions, you know, what does this tell me about the theory? What does it tell me about the underlying parameters, or what are the system parameters that would produce this result? So I think that's an understanding question. But if you have an experimental result and you want to generate like a new theory or a new explanation, I think that falls more in the creativity domain. So I think when you're, you know, working within I think understanding as defined here is mainly about how well you understand one theory. So you don't really change the theory, but it's just that you that you are able to generate good explanations of, you know, things happening within that theory.
So you challenged in this talk this idea that LLMs are like stochastic parrots, but to me it seems that the distinction is all about whether you interpolate the data or you extrapolate.
Yeah.
And I think that's what, like, interpolating, it's LLMs are typically very good at, but extrapolating, that's of course much harder because you haven't seen the data yet. And I think that's often what science is about. Like this rubber inventor, he went somewhere where the data never went before.
Yeah.
So is that something you also?
Yeah. So I think, I mean, so that's also, you know, so I think there's no examples yet of LLMs doing this kind of transformational creativity. So maybe there is some constraint there that, you know, the current architecture forbids them from doing that. But I think the claim by Bender is really stronger than that. So really she's saying, you know, it can't even learn arithmetic. It can't really. So I think I would associate that more with also saying like exploratory creativity is impossible, which I think that's kind of proven to not be true, because also, you know, you cannot, I mean, with these results within algebraic geometry, like these were just open questions that it answers. So this is not something that it can have found in its training data. So in that sense, I think that is an example where, you know, there's really some generalization going on. And then I think also, you know, I'm not closing the discussion here. So I think it's also important to think more about, you know, the philosophical implications of, you know, the potential for maybe transformational creativity in terms of what LLMs are capable of. Yeah.
So, I think the big plus.
Yeah, if I'm allowed.
Yes, super.
Hard to see now. Yeah, you said we mentioned often things like LLMs cannot do arithmetics, accounting. But then I wonder if we can. So I think I remember from a few years ago that these people that can do very quick, complicated arithmetic challenges on the TV, they were actually when they were put in the fMRI, they were actually activating the long-term memory a lot. And then they have, of course, rules how to transform something complex to something simpler, that they have a memory of what the solution is.
Yeah.
And so then that brings me to, not only arithmetics, but then maybe also generalizing it a bit more towards these kind of questions like interpolating. And to what extent do we hold them to some kind of bar that we don't even ourselves do?
Yeah, no, I think that's also another good point of critique against this kind of framework indeed. I think there's also papers that looked at LLMs for arithmetic, and then they kind of show that there's this bag of heuristics in the sense that there's like internal neurons that do like addition for numbers between 40 and numbers between 60 and 70 for the second input, right? So it's kind of a bit of a weird heuristic, but I think in the sense that, what you're saying is that humans also kind of use these heuristics, especially if you're, especially these people that do very fast arithmetic. So I think that's a good point in the sense that we shouldn't put humans on a higher pedestal than where they are.
It's kind of pointless to require that they can do it.
No, but I agree. So, but I think that the point was not necessarily that they require that LLMs can do this. I think that it was more like also a claim about the potential of LLMs. Like this is something that LLMs can never do.
But as a response also, so in the psychological literature, generalization and analogical reasoning are two important checks on this. So if it's a purely heuristic thing, you're not able to generalize it to new domains, for instance. And often then indeed you see that people if you ask them to generalize it, but in some cases, that's an additional, that's a bit like the what if. I think the what if is basically generalization.
Yeah.
So that's one of the biggest checks that we think for purely heuristic knowledge and really understand.
I had a question because my knowledge of the
So, you've talked a lot about, mathematics and physics, domains where you apply this, the LLMs. And mathematics has very strong axioms and theorems.
Yeah.
Physics also has pretty rigorous laws. My field is ecology, where the basis is much less rigorous and much more like assumptions that you can find all kinds of exceptions to and whatever. So how do we go about using AI systems in such systems? Because there is a lot of discussion right now about digital twinning using LLMs on large data sets, but are they just reiterating maybe false assumptions, or do we get stuck in a kind of historic flaw of thinking?
It could be. I think that's I'm not necessarily arguing one way or another in that regard. I think I think there's a good reason to think that LLMs maybe struggle more in these domains. I think one of the things also with this what I was mentioning about this test time inference and this LLM evaluation paradigm that's currently going on is also one of the interesting properties about that is that LLMs in those domains are really doing well on math and physics or math and computer science right now and programming, because those are things where you can very easily program an external evaluator to see if what the LLM produced is true or false. And this really gives the LLM a big boost in terms of relying on this evaluator can really guide what the LLM is doing. So I think indeed that probably the LLM will have more problems in these fields where you don't have access to this hard truth value.
Yeah, the question online from Bernd, and then we can go to Bernd.
Yeah, thanks. I hope you can hear me.
Oh, can't hear you. Cannot hear. So probably
Okay.
your microphone on your
Can you hear me now?
where on the.
Can you hear me now?
I can hear you, but can you hear me? No? Still no?
Hello?
Yeah.
Hi.
Hey.
I hear you, but you don't hear me?
Yeah, we hear you.
Okay. Yeah, so I have a two-part question. I really liked your comparison of human understanding and AI understanding, and I understood there was some problem, and you said let's look at how they respond and conclude from that if they have understanding. But well, first off, I was wondering, isn't that also still true by humans? Because you can also not look in the head of humans. And
Yeah, yeah.
secondly, now I think the latest developments are very much focused on world models. Like DeepMind has now this Genie model, for example, and that really try to model the world, with some physics inside. And wouldn't that give you then actually access to, um, you know, analyze that world model that it has built and actually, really directly see if it understood something on how
Yeah,
stuff.
yeah. So can you hear me now, Bernd?
Yes, yeah.
Oh, yeah, no, I'm not hearing Bernd. Okay, well, I'll talk. I think, yeah. Yeah, you can hear me. Okay, that's nice. No, okay. So I think, yeah. So I mean, this is also what Wout asked at the beginning. Is like we cannot really look inside the brain, but I think this theory was informed by also by looking at what goes on inside your own head. So I think there is some idea of what happens when you understand something that is involved by looking at the thoughts in your head that arise when you're thinking about these things and the step process that you're using. I think the main thing that you want to tease apart is basically, usually you have like maybe an internal response when you want to understand something, to when you get a question about this, and then you use this to guide basically your philosophical definition of understanding. So I think there is a factor of looking inside your own brain and seeing what's going on when you're reasoning, when you're looking at these things, that also went into these definitions in the literature. And I think this is also why it's important to kind of divorce these two things. And about world models and about I think that this would be a very good. I think this is an interesting direction. I think when you are able to look inside the world model, I think kind of this interpretability questions, like what's going on inside the LLM. I think that this is something that still we need to know a lot more about, because as I mentioned, there has been some preliminary work on this, and then you find a lot of heuristics. So maybe then you indeed would think that the generalizability is still a bit poor. So I mean, I think this is very interesting and should be investigated further to get a clearer picture.
Actually, my questions are like the questions of Bert. For me, it was like the question. I mean, I agree with Bob. We don't know what happens in our brain in terms of neurons and our chemical network. But is there a way just to understand the process of understanding? Because it's just what you discussed. It's okay, you give a question to see how well it answers, but is there a way to evaluate the process of understanding AI model that large language models?
Yeah, so I think I mean, this is again a little bit in this direction of this interpretability question, like what's going on under the hood. And I think this is still a very, an open question. What's going on? I think this is still early research in that regard. I think this is a very difficult problem right now because, these LLMs are so big, and, when the preliminary results are that, there's heuristics going on. So maybe this is a bit different than what's going on inside our own brains, at least, what we can see that's going on inside our own brains. That needs to be studied further.
An interesting case because Andre is going to the formal domains, and another case is chess. So chess is very interesting because we can build chess. These machines like AlphaZero to play chess, so they are basically based on a similar approach to LLMs. But LLMs themselves play really badly chess. And they're really good in math. I don't really get it because that's also a formal domain, and there's a lot of study material out there to do chess. But I don't know where you try it. If you give an LLM any chess puzzle, it will actually talk a lot of chess. So it will talk about open lines and positions, and all sounds really, really good. And then it comes up with a move which is just total nonsense. Yeah. So why is chess so hard and math so easy for it?
Yeah. No, it's a good question. I don't know the answer to this, but I think one part is that I think the companies are focusing also a lot on, like what I was saying, you have external evaluators on math. So I think there's a lot of training also inside the LLM happening on math problems. So I don't know, maybe if you do the same thing for chess, and the LLM could also become better at chess. I think that could be the case. But I think in principle, yeah, it should be similar. Like I think you can probably phrase any chess problem also as kind of a math problem in some sense. So I think, yeah, I would say that it's due to the training process.
You didn't really go into the value of creativity.
Yeah.
Elaborate on this, but I'm curious. A lot of mathematics was about asking the right questions.
Yeah.
Right. So I think there's a lot of domains in mathematics where sort of regurgitate the same techniques and stuff, and there's other maybe more abstract, or I find them to be harder. Is that really part of what you measure, like asking the right questions? Because I think you can just in event, like in principles, just you have some axioms, you can build this. Right?
Yeah.
You have lean, whatever.
Yeah. No. So I think this is also so we're not measuring this in this benchmark, but I think there's also people that have looked more into this question, like having LLMs generate research questions and then using expert to evaluate, like, are these good research questions? So I think this is something that other people do. I think this is harder to put in benchmark form because, again, you need some way to kind of verify a priori of like how good it is, because this, in terms of benchmark, this would require a lot of effort of people evaluating whether this is a good question or not. So this is why we went more in this route. But yeah, it's interesting.
Maybe like one thing also is that here it seems like answered correctly is really like a binary thing.
Yeah.
But I think, well, especially in mathematics, a lot of times it's also about the art of the shortcut.
Yeah.
Right. So you can get from to the right answer in a very roundabout way, or like a trivial way, or you can be creative and smart and find the theorem that proves it in 2 steps. So in that sense, that's answered correctly. Spectrum.
No, I agree. So I mean, this it's a shortcut in this sense. So you cannot capture everything in this way. And I think, maybe, it's a good. I'm thinking if you can phrase this in a yes/no question, maybe that's hard. Maybe that's not possible. But I think, you have to make a shortcut somewhere to make it into a feasible benchmark. And I think also in that case, the value would not be, the proof itself. The value would be indeed the shortcut. But yeah, then maybe if you ask like a question, can you prove this in 2 steps? And it's a bit leading maybe. So it's hard, but it's interesting to think about.
Yeah, so maybe one step back. I mean, to what extent does it make sense to hold LLMs to the same standards as humans? I mean, shouldn't be some sort of try to think of what do we want with LLMs and how can it be as good as possible in being LLMs instead of trying to be humans, which they are clearly not.
Yeah. No, so I mean, I would say that in terms of, this product definition of creativity, that's kind of what we want. We want to create creative products. So that's what we want the LLM to do. So in that sense, I think we're already doing it in that step. I think in the agency, then there's definitely like a human component to that. So I'm not saying that, this is the only thing that we should focus on in LLMs, but I think it is an interesting observation that, this fourth part of agency, this evaluation, is something that's currently like in the main paradigm of LLM training. So I think there's still kind of a back and forth there. But I think the creative products, I think that's what we want the LLMs to produce. So I think in that sense, that is kind of human agnostic.
Now, it's also a discussion about trust. Yeah, we use these systems all the time, and we trust systems that can actually explain what they do. And you also explain experts that can explain what they do. So it's quite interesting to know how they get to these masters.
But personally, for me, trust would be a more important benchmark than creativity. Maybe you should have some sort of per LLM score. Like for what I want to do today, I want a super trustworthy LLM, and for my job tomorrow, I want a very creative AI, or yeah.
Yeah, no, yeah, that makes sense. I mean, yeah, I think it's different, yeah, directions.
You presented some parallels between human creativity and LLMs creativity. And I don't know if it's inside your expertise area, but how about the emergence of consciousness? Because humans are conscious and somehow we know it. But can one day LLMs be able to be conscious, or are they already conscious?
Yeah, so yeah.
It's a question.
Yeah, no, I mean, yeah, it's an interesting question, but I did kind of expressly try to avoid that question here. So I think that's also kind of the premise of what I'm doing here, because you know, I think it's an interesting question, but I think it's kind of dangerous to conflate kind of on the one hand this consciousness, this hard problem, right? This is really what kind of what Bender is doing with this stochastic parrot hypothesis, and also then conflating it with, you know, the practical things an LLM can do right now. So this work is really focused on the practical side, on this functional side, and you know, yeah, I haven't really thought that much about this problem of consciousness.
Yeah, we also, as I said, research in this direction, but we go to these other type of benchmarks, like the ARC task.
Yeah.
You know, the ARC, and we use them on bar problems, for instance, because these are tasks where you can create enormous amount of new items.
Yeah.
And they cannot be, the memorization explanation is then out of the window.
Yeah.
So do you see a comparable approach? Like I don't know whether people know what the ARC approach is, but the ARC is a kind of, they show certain matrices, and then you see transformation from one matrix to another matrix. There are colors changing. Then you get a new matrix, and you have to do the same trick. So you have to understand what's happening from matrix A to B. So maybe reds changing greens, to give a simple example. And you have to do the same transformation in the second matrix.
Yeah.
But then you can make very advanced tricks there.
Yeah.
And you can generate enormous amount of new items in this way. And this, then you get a bit rid of this memorization alternative, because that problem of this approach is always that people publish these benchmarks at some point.
Yeah.
And then you don't see the data, and then you have to start all over. So is there a way to prevent this
Yeah, no,
this type of benchmarking?
Yeah, no, I think that's hard. Yeah, I think that's a smart way to do it in terms of this ARC approach. But yeah, I mean, I think again, I think it's also interesting, and it will remain interesting to also see, you know, how well does it do on physics instead of these more abstract reasoning tasks. So I think therefore this is important, and then yeah, I mean, I think this is a question that will a problem that will remain in the sense that you will always deal with this contamination problem. Yes, I don't.
If there are no more questions, I would say we thank Merijn again.